Alright, so welcome to my video segment as I revise the GCE 2025 paper 2. So we are going to be looking at questions systematically, question 1, question 2, and so on and so forth. So for question number 1, the first part there says simplify, and they wanted you to simplify this algebraic expression that you have there. Now, if you notice, you have got multiplication, you also have division, so therefore you fall back on what we call as being BODMAS. So if you look at the order, how do we carry out the order of multiplying? So the order is bracket of division, multiplication, addition, subtraction. So you need to start with division. So because of division, so those terms that are closer to the division sign, I can actually put them in brackets. That's what I mean. So if I rewrite that by putting up the brackets around those terms that are closer to the division sign, if you notice there, it simply means that for the terms in the bracket to your right, it simply means the denominator will become the numerator and the numerator will become the denominator, so they'll exchange position. So it is going to be, therefore I can write as a squared, b raised to the power 3 over 2c multiplied by ac squared over 2b multiply. So that will change to multiplication sign. So that is going to be multiplied by. So the moment it changes to multiplication sign, like I said, they will exchange. So the 2a goes on top and the b squared c will come to the bottom. So if you want, you can cancel them out. Those terms that are common, you can cancel them out. Or the easiest is simply you expand them first of all, then you cancel, then you can reduce them. So there, how many a's? It's a times a. And how many b's? There are 3b times b over 2 multiplied by c. Multiply by there, it is a times c over 2 times b. Multiply by there, it is 2 times a over b times b multiplied by c. So we can cancel out and try to see if we are able to reduce them. For example, I can cancel this c and that c can cancel, this c and that c will cancel. If I cancel the 2 b's, I'll cancel the 2 b's on top. I'll cancel this b and I'll cancel that b on top. If you notice, I can cancel that 2 and cancel the 2 there. So what have I remained with there? A times a, that gives you a squared over 2 multiplied by there, it is just a over there, you have just remained with 1 times there, you have remained with a over again 1. So a squared times a, that will give you a raised to the power 4 over 2 times 1 times 1, and that will simply give you a 2 there. And this is the final answer that they wanted you to come up with. So a squared over 2a was the final answer. So what is important when you have such algebraic expression, you need to remember to use BODMAS to help you the order in which you need to carry out your mathematical operation. All right, question number 1b. Question number 1b there was saying that for the geometric progression, so they have given us the sequence in a geometric progression, 60, 30, 15, and so on and so forth. Now, if you still remember some few concepts that we taught you, if you have term 1, the term 2, and term 3, and this is a geometric progression, we talk about the common ratio. And how do you get the common ratio? You can get term 2 and divide it by the preceding term, which is the same even if you get term 3 and divide it by the preceding term, which is term 2, as long as the terms are consecutive, they are following each other. Then the general formula, if you remember, Tn is equal to the first term, the common ratio raised to n minus 1, so you shouldn't forget that. So now for the sequence, they have actually given us there 60, 30, 15, and so on and so forth. We can find the common ratio, that is b Roman 1. How do we get the common ratio? Remember, this is more like you have got your T1, this is like your T2, and that is like your T3. So you can just say T2 divided by T1 or T3 divided by T2. It will be the same. So it will be 30 divided by 60, and 30 divided by 60, 30 there 1, 30 there will give you 2, so it's a half, or if you want, it is a 0.5. That's a common ratio. Now if you notice the question, it says find the 60th term. So we want to find the 60th term. So how do we get the 60th term? You can employ the formula. You can use the formula Tn is equal to the first term, the common ratio raised to n minus 1. We know what the first term in that sequence is. It is 60. The common ratio, it is half, or 0.5. And since they are saying the 60th term, it means when n is equal to 6. So you just substitute in that formula. So it will be T6 is equal to the first term, will be 60 multiplied by the common ratio, which is a half, but this all raised to my n, which is 6 minus 1. So that is going to be 60 multiplied by 1 over 2 raised to 6 minus 1 will give you a 5. Remember, if you want, according to your laws of indices, if you have a over b raised to the power n, that is the same as a raised to the power n and b raised to the power n. So if I have 1 over 2 raised to the power 5, it's the same as 1 raised to the power 5 and 2 raised to the power 5. 1 raised to the power 5 will still give you 1. 2 raised to the power 5 will give you a 32 if you use your calculator. So let me just try to use also a calculator, so 1 over 2 in this case raised to the power 5 will simply give you 1 over 32. So it will be 60 multiplied by 1 over 32. So remember, 4 can go there. If you want, you can just say, if you want, it is the same multiplied by 60. It is going to give you a 15 over 3. That's what we, 15 over 8. That is the term in the 60th position. So this is your final answer, 15 over 8. If you want, you can reduce 4 there. 4 there, 4 into 32 is 8, and 4 there will give you a 15, and that's why we are getting 15 over 8 there. Now this is applying the formula. Let me show you that you can also work out this one without applying the formula, as long as you know your common ratio. So I'm working on the same problem. I just want to show you, give you concept. I'm not just answering, I'm just trying to help you so that you can get more concept. So since we know the common ratio is a half, if you know the common ratio, you can get the next term by multiplying by your common ratio. So just keep on multiplying by the common ratio. So 60 multiplied by half will give me 30. That's just the same as you are dividing. So 60, it's, if you want, it's like 60 divided by 2 give you 30. 30 divided by 2 will give me 15. 15 divided by 2, that is going to give me 15 over 2. 15 divided by 2, that is going to give me 15 over 4. 15 over 4 divided by 2, that is going to give me 15 over 8. Now if you look at this one, this is the first term, this is the second term, this is the third term, this is the fourth term, this is the fifth term, and this is the 60th term. So you can see the 60th term is simply 15 over 8. Therefore you can say T6 is equal to 15 over 8. So that's the way you can also do it. As long as you know the first term and the common ratio, you can know the sequence in that geometric progression. All right, so that is the way you can do it. Let's move on to B. Roman 2 there. So Roman 2 there says that it says that we find the geometric mean of 15 and 3.75. That was also 2 marks. So the geometric mean, if you want to get the GM, the geometric mean, you just multiply the two numbers. In this case, you multiply 15 multiplied by 375, then you find the square root of what you get. So the geometric mean there is going to be, so it will be 15 multiplied by 3.75, that is going to give me 56.25, but we find the square root of this one. So what will be the geometric mean? The square root of 56.25, that is going to give us a 7.5, and this is the final answer that they wanted you to get there. That's the geometric mean. All right, for two numbers. So just multiply them and find the square root there. That's what we mean. B, Roman 3 says the sum to infinity. Now, for you to get the sum to infinity, remember, the sum to infinity is equal to the first term over 1 minus the common ratio. And this is only true when the modulus is actually less than 1. That's what it simply means. If the modulus of the common ratio is less than 1, that's what we mean there. So now it simply means the first term is 60, the common ratio is simply a half. That's what we mean, so we replace there. So the sum to infinity will be equal to 60 over 1 minus the common ratio half. That would be 60 over 1 minus half will still give you a half. If you work out mathematically there, it is the same as 60 multiplied by 2, which is going to give you 120. So the sum to infinity, therefore, the sum to infinity is equal to 120. That's what we mean. If you're not comfortable, 60 divided by 1 over 2, you're going to find that that is going to give you 120. So this is the way you needed to do question number 1 for the GCE 2025 paper 2. Thank you so much for watching, and watch out for question number 2 in my next video.